Hi everyone, my name is David Bach. This is my final CS50 project called Using Extreme Gradient Boosting to Predict Ozone Exceedances in El Paso, Texas. There's my information. Ozone is a dangerous air pollutant that's formed in the atmosphere when nitrogen oxides react with volatile organic compounds in the presence of sunlight. And EPA has set a standard for this pollutant. If an area experiences pollution over 70 parts per billion averaged over an 8-hour period, then it's considered an exceedance day. So I wanted to use machine learning to predict whether an exceedance day would occur using various meteorological and pollutant inputs that are known to correlate with ozone levels. And other studies have looked at a variety of different models to try to perform this task, including artificial neural network, k-nearest neighbor, and extreme gradient boosting. So first I gathered my data from the Texas Commission on Environmental Quality in a CSV file and did some processing on it using some data cleaner functions that I created in Python. Then I tried to run k-nearest neighbor to see if I could predict whether an exceedance would occur or not based on the inputs. Unfortunately, this model did not work very well. Ozone exceedances are very rare. For example, even in a very polluted area like El Paso, you may have only 10, 12 exceedances per year. And so the model was predicting, it was erring on the side of just being very conservative and got a high accuracy that way, but a very low true positive rate, which is what we're interested in. However, XGBoost did a lot better, especially when combined with synthetic minority oversampling, as we'll talk about in a second. XGBoost is an ensemble machine learning method that uses gradient boosted decision trees, basically creates however many trees you want in sequence, and each new tree is adjusted a little bit in terms of the algorithm that it uses based on the gradient from the prior tree of the gradient that was used to calculate the loss rate or the error rate. And so it moves in the direction that it thinks will reduce the loss. And then it basically aggregates the results of all the different trees it's created to make its prediction. Synthetic minority oversampling basically accounts for the relative rarity of the event of interest, here the exceedances, by creating synthetic examples that have similar characteristics. So it basically expands the data set so it's not quite as infrequent. So here's my final results from this program. As you can see, correctly predicted ozone exceedances with 98%, and correctly predicted non-exceedances with 91%. So very good accuracy. There's other steps that I don't have time to